Today is Monday, September 19. So today we will continue to finish the quadratic functions, and then we will start power functions and polynomials. I haven't graded your quiz yet, so I will grade it today and tomorrow. And then on Wednesday, we will go over the quiz and the mistakes. Okay? This week you don't have any quiz, but you see our homework is due on next Monday. Okay? So you have only 1 week to finish all your homework assignments. Okay? So yeah, I hope you can try to do your homework as much as you can. And remember, you have unlimited attempts. So if you have a mistake, you can redo the problems and then until you get a higher scores. Okay, everybody? And next Monday, we'll have the quiz 3. It's going to be based on section 3.1 to 3.4. And then the Friday, September 30, we have our first exams. So the first exams cover chapter 1 through session 3.4. Okay, everybody? On our course website, at the very bottom, you see this practice exams and solutions. So you first do it with pencil. Okay, try to do it within 1.5 hours. And then after you finish, you can click the solution and then grade your work. Okay, so each problem has some points. So for example, this is problem 1. So part A is worth 2 points. So you grade it. Okay, so if you're correct, make a check mark. If you're wrong, write a correction next to it. And also estimate your scores. Okay, so you estimate your score for each problem, and then you add them up to get a total score. Okay, so because I want you to compare your practice exam score and your actual exam score. Are you improving? If yes, that is good. But if someone get very high score on the practice exam but low score on the actual exams, then you need to come to see me. Let's figure out a way how to improve. Maybe change our study habits and make some study plans. Okay? So that is the practice exam. The practice exam is due next Friday on the exam date. Okay? So exam is next Friday. Homework is due next Monday. So if you haven't finished your homework, please do it as much as you can. All right. That's what I hope you can do your homework weekly. Yes?
Is the practice exam already open?
Yes.
Okay.
Yeah, it is on the course website. It's not in Blackboard. It's on the course website. Right. Okay. Right. And so remember, I want to give you more time for the exams. So I want to give you 1.5 hours. So I will be here before 12:20. So please come early, then you can take the exam so you have enough time. Okay? I just want to give you more time in case you need it. So all of you able to come at 12:20 on the Friday, September 30? Yes. Okay, good. If you cannot come, you don't have to come. You can come in our regular class time. But just in case if you cannot finish within 1 hour and 7 minutes, then yeah. So I want you to have more time. I want to give you this opportunity. But for those of you who have a class right before us that you cannot come early, you can email me. You can schedule a makeup exam before that day. Okay, so we schedule makeup exam before the class exam time, but not after. So if you cannot come early on that day and you want to have 1.5 hours to take your exam, you can let me know earlier. Maybe we can schedule to take the exam on Thursday afternoon. Is that clear, everybody? Yes, so let me know earlier, then we can make arrangements. Our rule is no makeup exam after the class exam time, because after the class exam time, everybody knows what's on the exam, so it's unfair to the student who take the exam on in the class time. Okay? All right. Yeah, so please do your homework, and the homework is due next Monday. Okay, and then this Wednesday we will talk about the quiz and the mistakes. Okay, that's the plan. And then, yes, remember last time one of your classmates asked me this problem. 5 minus 5i was a correct answer, but why we input 5 minus 5i in the Mobius and it said this is wrong. And then I check it, and then I figure out why. Because the Mobius, they don't recognize 26i. So you need to put the asterisk between the 26 and the I. Yes?
I did that and I still got a wrong answer.
Really?
Yeah.
Ah. What did it say? Interesting. Oh, that's so weird. Okay. Let me. Okay. Yeah, this is interesting. Let me go in and see what is wrong. So this is here and content 1.4. No, 3.1, right? So 3.1. Okay. And a simplify complex number. No, not this one. This one. Okay, let's see. Okay, 26. Okay, so 26 minus 26 times I. And how do I do? Oh, interesting. Okay. So, okay. How do I do? Yeah, it's the same, right? Okay. Okay, I think it has this problem. Okay. Yes. So I think yes. Print screen this problem to me because let me see. Okay. All right. So your okay. I will change your score from 9 to 10. So I will manually add your scores by 1 in Blackboard. Okay. Yes. Okay. Okay. All right. So yeah, I will do it after the due dates because some of you still working on your homework. So after the due date, which is September 26th, the next Monday, that's the first due date of all the homework assignments up to the 3.4. Yes. And then after that, I can add your scores. I will add all the score by 1. Okay. All right. Yes. Interesting. Okay. Thank you for letting me know. And then some of you asked me these questions. I think this is in 1.4, the composite function. All right. So let's see. Okay, attendance. Thank you. Okay, so this problem to find the composite function. Do you remember this problem from your homework? Yes? Some of you might not have this problem because sometimes it randomizes to pick some problems from the question bank. Okay, so here we have the number of bacteria in refrigerated food products is given by the following, where capital T is the temperature of the food. And when the food is removed from the refrigerator, the temperature is given by T of small t is the time. So 7T plus 1.5, find the composite function and of T of T. Well, this means whenever you see the capital T, replace it with 7T plus 1.5, right? So we got, 23, oops, let me, okay, so copy this page and do it here. Okay. All right. So, yes, so 23, and then whenever you see capital T, replace it with 7T plus 1.5 squared minus 56T. So capital T is 7 small t plus 1.5 and plus 1. Right? This is a comma. It says capital T is from 3 to 33. So the formula stops after at 1. Okay, everybody? So this is the composite function. And then part B, find the time when the bacteria counts reach 6, 7, 52. Okay? So you can separate this as 2 steps. The first step is you find the temperature where the bacteria reach this number. Okay? And then after you find the temperature, you can plug in this function to find the time. Okay? So it's easier if you think of this way and like 2 steps. So step 1, find the temperature. So we have 23 t squared minus 56t plus 1. Okay, so this is the number of bacteria. We set it equals to 6,752. Yes, everybody? And this is the quadratic equation, right? We move all the terms to the left-hand side. So 23t squared minus 56t minus what? 6751? Yes, because 1 subtract that is this. Okay, good. I guess we cannot factor it. The number is so ugly, right? So let's use quadratic formula. Okay? Quadratic formula. So T is what? 2A. A is 23. Are you familiar with the quadratic formula? Yes, we talked about that last time. So 2A at the bottom, and then negative B. So, which is 56. Plus or minus square root of B squared minus 4AC. But do you see that C is negative? So negative, negative, make it positive. Right, everybody? And the temperature, we want to pick the positive number. Okay, so plug this in your calculator, right? Do I have a calculator here? Okay, so let me use decimal. Okay, so this is an online calculator. 56 plus, okay. So 50, okay, let's do parentheses. Okay, 56 plus square root of 56 square, and then plus 4 times 23, oops, times what? 6751. 6751. And then all over 2A, so 2 times 23. Do you see I got 18.393? Yeah? So 18.393. Sometimes if you want your answer to be more accurate, then you keep going. So 0654, okay. 0.0654. That's my temperature. And then the second step, find the time. And what is the formula? So T equals 70 plus 1.5. And that equals this number, right? 18.393 something. So we want to solve for T. So both sides subtract 1.5, right? And then I get 70 equals this 18.393 something minus 1.5. And then divided both sides by 7. Yes, everybody? So we go back, this answer, so parentheses, answer, minus 1.5 parentheses divided by 7. This I get 2.413. So T is 2.413. And then that's the answer. Okay. Yes. So T, this is the time. So 2.413 is the answer of time. So far, so good, everybody. Yeah, so that's why some of you, if you answer 18 point something, this is wrong. This is the temperature. This is not the time. So far, so good? Okay. Right. If you have any questions, just let me know, okay? Or you can paste your questions on this question sheet, and then sometime if you also remind me you posted something there, then we can go over that in class. So this we already go over that. Okay. Yeah. Okay. So far so good. All right. So let's continue. Last time we talked about quadratic functions, right? Let me review what we learned. Okay, so you have some space at the back of this page, right? Let's do a little review here. Okay, so quadratic function, y equals ax squared plus bx plus c. This is called a general form. And it's also equals to a times x minus h squared plus k. Bless you. This is called the standard form. Like the line we have slope intercept form and point slope form. Okay? So yeah, linear equation we can have different form. For parabola, we can have the general form and the standard form. The standard form tells us the information. We have vertex, so the vertex is h comma k. And you gotta be careful. This h and this is x minus h. Okay, so this is minus h, then your x coordinate is the h. Therefore, if you have like x plus 3 squared, then your h will be -3. Okay, it's always the opposite sign there, right, everybody? And we have the axis of symmetry is what? X equals h. It's a vertical line. So don't give me a number h. Give me an equation, a line, vertical line. X equals to something. Okay, so this will give us the, so this is the vertex, and then if a is greater than 0, we have a parabola opens up, and then the vertex is h comma k, and then this is the axis of symmetry, x equals h. So far so good, everybody? Yes? And then if we look at this general form, the C, okay? C will give us the y-intercept. So the y-intercept is 0 comma C. Yes, everybody? And so we have some formula to transform the general form to the standard form. The formula is, okay, So we have from here to here, h equals negative b over 2a, right? And the k is f of h. So far, so good, everybody? Okay. And then, so if our picture is like this, if the parabola, okay, opens up, so if a is greater than 0, okay, then this is the y-intercept. This is the c. And how do we find the x-intercept? Okay, so c is the y-intercept. The x-intercept is where define the x such that the y equal to 0. Remember, we set the y equal to 0 and we solve for x. That's exactly the quadratic equation. Right? We set the y equal to 0. This is exactly the quadratic equation. Right? And so we have the quadratic formula. X equals 2a negative b plus or minus b squared minus 4ac. Right, everybody? And therefore, it depends on whether the things inside the square root, whether it equal to 0 or greater than 0 or less than 0. We have different cases. So we call the things inside the square root, we call this to be the discriminant. So b squared minus 4ac discriminant. Okay, discriminant. Okay. All right. So b squared minus 4ac. Okay. So first case, if the discriminant is greater than 0, then our parabola will intersect the x-axis in two different points. That means this equation has two real roots. Okay, so equation has two real roots. Yes, everybody? Because, well, the real root is this guy. One is plus, one is minus. Because if the discriminant is positive, well, this is a real number, right? Square root of positive number is, it might be irrational, but it's still real numbers. So that's why we have two real roots. Okay. And the x-intercept is just comma, the parentheses, this guy, comma, 0. They are the x-intercepts. Okay, if the discriminant is 0, then we only have one real root. Okay, that means our parabola just touch the x-axis. Okay, everybody? Yes. So we will end up getting a complete square. So it just touched the x-axis. And you can see in this case, if we want to use the standard form, right? Okay, so in this case, the decay would be 0. So you can see the y equals a times x minus h squared. Is that okay, anybody? Oh, by the way, the real root, let's call the real root to be R1 and R2. Okay, let me call the root R1, R2. R1 is the one with the positive, R2 is the root with the negative in front of the square root. Okay, then you can express the quadratic equations or the function to be a times x minus r1 and x minus r2. Okay, so yes, the germ form can be written as a times x minus the first root times x minus the second root because they both are roots. So x minus the root this is a factor of the quadratic function. And then the third case, If the discriminant is negative, that means the parabola lies above the x-axis if A is positive. Right, everybody? So in this case, we have no real root. Okay? Well, think about it. The thing is that the square root is a negative number, right? So you expect to have complex roots. Okay, everybody? So in this case, no real roots, but we have two complex conjugate roots. Okay, so you can think of these are usually we use the notation alpha plus or minus beta I. Because we don't want to use A and B because A and B then they are different things here. So the complex conjugate alpha plus or minus beta I. So alpha is the real part, which is the minus B over 2A. And then the beta, because, okay, if you want me to write it down, okay, the alpha is minus B over 2A. The beta will be the imaginary part. So in that case will be, so because this guy is negative, so if you factor out the negative, the square root of the negative 1, it will give us the I, right? Then the remaining, because we factor out the negative, so the remaining is going to be, we flip it. So 4AC minus B squared over the 2A. This will be the imaginary part. Because B minus 4AC is negative, then 4AC minus B squared will be positive. Is that okay, everybody? Mm-hmm. So the complex roots will always appear as pairs for the complex conjugates. So these are the three possibilities. We either intersect the x-axis with two intersecting points, two x-intercepts, or we just touch it. So which means we can rewrite the quadratic function as a complete square. Or it does not touch the x-axis, so we have no real roots but two complex conjugates. Questions? So far? No? Okay. And then if A is positive, then we know our parabola goes up, right? When open up, then this is H comma K. So the minimum value is, so f of H equals K. So the minimum value is the y value. Do you see the y value is K? Right, everybody? And this is at x equals to H. Is that okay, everybody? So f has minimum at x equals H, and the minimum value is the K. Okay, everybody? How about when A is negative? Wow, do you see we have maximum? The maximum value is the K. Okay, and we get the maximum value when x equals to H. Okay? How about domain? Well, domain is all real numbers. See your parabola. This side goes to infinity. This side goes to infinity. So domain will be all real numbers, right? But how about your range? Well, your range is the minimum is the K, and then the maximum is no maximum. It just go up forever, right? So the range will be from K to infinity. Yes, everybody, from the picture. And then here, how about the domain? Well, what's the domain? If A is negative, are real numbers. But how about the range? It goes down forever, right? So from, yeah, exactly. So negative infinity to K brackets. Brackets means we include the endpoints, right? See, this point is here, it's not missing. So far, so good, everybody? Yes? Awesome. So, okay, save that. Okay, now let's go back to our example. Okay, so this is all the things we learned about quadratic functions. So go back to our example. Okay. So, why I'm not able to make it bigger? Okay, how about this? Okay. All right. Okay. So, okay. The path of a baseball after being hit is given by the following function, where fx is the height of the baseball in feet, and x is the horizontal distance from the home plate in feet. What is the maximum height of the baseball? Okay, so we hit the baseball, okay, and then it goes up, boom, like that. And then we're looking for, what is the maximum height? So this is the maximum height, right? And how far will the baseball hit the ground? So we also want to find out how far, what's the x value such that it hit the ground. Okay, so part A, maximum height. Well, this is the same as you want to find the vertex, right, everybody? So let's find the vertex. So vertex h comma k, and well, we are given the general form, right? So a x squared plus bx plus c. So the a is, so that's the a, negative 0.0032. And what's the b? 1. And the c is 3. Okay, so use our formula. H is negative b over 2a. Right? Negative b is 1, 2a. So 2 times a is negative 0.0032. Oh, do you see the negative cancel? Right? Okay. So do you have your calculator? Put this in your calculator. What do you get? So please, everybody, use your calculator, the radio calculator to pass. Especially this is website, right? Sometimes if we do with the word problems, the numbers are not so nice. So you need the calculator. So 1 divided by 2, and then divided by 0.0032. What do you get? 156 and 0.25. Right, everybody? Awesome. That is the H. Now, K. K is f of H. So that means whenever you see X in the expression, you replace it by 156.25. So we have negative 0.0032x. My x is 156.25 square plus x. X is 156.25. And then plus 3. Okay, what is this number? Give me 3 decimal places. 81.125. Oh, is this exact number? 81.125. Good. Feet. So this is the part A. Okay, we know the maximum height is 81.125 feet. And actually, we also know that the horizontal distance that this happened. The horizontal distance is 156.25 feet. Is that okay, everybody? Awesome. So that is part A. We find the maximum height. And part B, it hit the ground. So it hit the ground. means the y value is 0. We are looking for the x-intercept. Right, everybody? Mm-hmm. So we set the y equal to 0 and solve for x. So hit the ground. So the y 0.0032 x squared plus x plus 3. We set the y equal to 0. Solve for x. Well, and quadratic formula, right? Yeah, many of the word problems use quadratic formula because the number are not so nice that we can fetch them, right? So in general, use quadratic formula. So 2a, so negative 0.0032. Don't forget to put the parentheses because if you make the parentheses, it becomes 2 minus that. No, we want to have 2 times negative of that. Okay, multiplication, not subtraction. So don't forget the parentheses. So 2a negative b, negative b plus or minus b squared minus 4a. Oh, do you see the negative and the negative in front cancel, become positive? Yes, everybody? So 0.0032 and then the 3. So far so good, everybody? Mm-hmm. Okay. So, because what we get 2 numbers. What are they? So first do the positive and then do the negative, and so we should get 2 numbers. What are they? Yeah, everybody learn how to use your calculator. Sometimes it's very important the parentheses, because if you forget the parentheses, you might not get the right number. Mm-hmm. So what number do you get? What do you get? Calculator, calculator. What number do you get? What number do you get?
I got negative 2.97 and 315.4.
Right, everybody? Okay, very good. So, because x, we should pick the positive number. Right, everybody? Yes? So we should not pick the negative number. So don't pick this. So our answer is this feet. Okay, so that is how far we hit the ground. Okay, so actually this number will give us this x-intercept. But this is impossible. You can go backwards, right? So this is the 350.47. So far, so good, everybody? Mm-hmm. Do you have the same answer? Okay, awesome. So this is example 5. All right. Example 6. Okay. Write the equation for the parabola. So here we are giving the parabola. Okay. All right. We want to write down the equations. Okay, let's find the vertex. Where is the vertex? Yeah, nearly 1, 2. Can you also give me a point on the parabola? Yeah, 92, 91. Okay, so this 2 information hopefully can help us to figure out the equation. So, equation, do we use the general form or the standard form? if we know the vertex. The standard form, yes. So we have y equals a and then times yes. H. What's H? Look at your vertex. What's H? -1. And what's your K? 2. So we plug in. Okay, what's inside the parentheses? X. Very good. +1. Because when we plug in, it's minus -1. It becomes +1. Right, everybody? All right, and plus K. K is 2. Yes. So, we just need to find the K. But we can plug in this point, right? And by the way, you can also plug in this point. Probably this point is easier. Do you agree? Yes? This is 0, -1. Okay, so this is 0, -1. Okay, so because it passes through 0, -1, so you plug in x is 0 and you plug in y is -1. So -1 equals a, x is 0. See, you plug in 0, then 0 plus 1 is just 1. Right, everybody? Yes. And 1 squared is 1. So we have a plus 2 is -1. What's a? Yeah, -3. Good. Almost done because we need to write down the equation. So put everything back in. A is -3. And then, yeah, we plug in here, right? So we have x plus 1 squared and then plus 2. So this is the equation for the parabola. Because the problem didn't ask us to have general form or standard form, you can put it here. So standard form is okay. Any questions about this section? Brenda? All good? Yes? Awesome. Yeah, we only have like less than 2 weeks, then we have the first exam. I hope you can study hard, and when you have questions, come to ask me or go to find a tutor. Okay, use all the resources you can. Okay, and study hard. Hopefully, you can get a good grade. Okay, so 3.3 power functions and polynomials functions, and 3.4 graphs. Okay, a power function is a function that can be represented in a form k times x to the n. But k and n are real numbers. K is known as the coefficient. So this is the coefficient of x to the n. Okay, so here are some examples. F of 1. Well, this corresponds to the n is 0. Do you agree? The n is 0, x is 0 is 1, so we have constant function. The constant function, just horizontal lines. And then when n is 1, we get x, right? X is the line, identity function. When n is 2, we get quadratic function. Remember this parabola? N equals cube. Cubic function, like this, right? And 1 over x. 1 over x is the reciprocal, right? Reciprocal is like this. Yes, everybody? And then 1 over x squared looks like this. Because it's going to be x squared greater than 0. So 1 over x squared always greater than 0. So always above the x-axis. And then this is the square root. Remember, everybody? Square root. And then this is the cube root. So cube root, square root is like x to the 1/2. Cube root is like x to the 1/3. So cube root, it looks like this. Right? Do you remember our math move? Yes? Right? Okay. Okay. And then, in general, power function. If the power n is a integer, is a positive integer, and then depends on whether it's odd number or even number. This is the picture. Okay, so this picture is yeah, y equals kx to the n, and n is let's suppose n is greater than 0 and is an integer. Okay, and if n is even, then the picture is very similar to the graph of x squared. Do you agree? And if n is odd number, this picture is similar to x cubed. Do you agree? Mm-hmm. And how about when k is negative? Well, think about negative x squared. Well, negative x squared reflection over the x-axis, right? Remember, if you put a minus sign in front of the y, that's reflection over the x-axis. That's why everything you flip it over and then so it is downstairs. Right, everybody? Mm-hmm. And if we have a power, then refraction over the x-axis. So this point go down here, so this point go up there, so we get the picture. Okay, everybody? So you can imagine x squared for when n is even power. Think about the graph of x squared. This is similar to that, right? And if n is up, think about x cubed. Okay, so this graph is similar to that. And then you know all the n behavior after you draw the picture, right? So this, when x goes to infinity, your y goes to infinity. When x goes to minus infinity, the y also goes to infinity, right? This picture, when x goes to infinity, y goes to infinity. When x goes to negative infinity, the y goes down, negative infinity, right? And then here, oh, no matter when x goes to infinity or minus infinity, the y goes to negative infinity. And then here, x goes to infinity, y goes to negative infinity. X goes to negative infinity, y goes to infinity. Right, everybody? So you draw the picture, then the picture will tell you, oh, what's the n behavior. Okay. A polynomial function of degree n is a function that can be written in the form of a sub n x to the n plus a sub n minus 1. So the sub n means it's an index. So a sub n is like a number, a scalar. Okay, everybody? That's the coefficient of x to the n. And then all these ai's are the coefficients. And so a0 is the constant term. And so a0 is the constant term. A sub n is called the leading coefficient. Okay, leading coefficient. Okay, and a sub n x to the n, this is called the leading term because it's the highest power term. Okay. And polynomial are continuous and smooth. Well, what does that mean? Well, you can draw the picture without lifting a pencil from the paper. That is continuous and smooth. Okay? And this means no gaps, no holes, no cuts, no corners. So this is not continuous. See, you draw it and then you lift your pencil and then you start here again. So this is not continuous. Oh, here there's a hole. So there's a hole there. So it's like you lift your pencil up. So there's a hole there. And this is not smooth. This is continuous, but it's not smooth because it has a corner here. Okay? And also here is continuous but not smooth. It has a corner. Okay? So polynomial is continuous and smooth. All right. Oh, wait. So here we also have the picture. This is the leading term. N is the degree. A sub n is the leading coefficient. So the highest degree term of a polynomial is called the leading term. Okay. The leading term determines the end behavior of the polynomial. Why? Okay, end behavior. it means x is going to infinity, right? X is bigger, bigger, bigger. Let's say we have, for example, how about, okay, 2x to the 4 minus 3x minus 7, something like that, or plus 7. Okay, x goes to infinity. Think about it. If I put x equals 10, well, x to the 4th. X to the 4 is what? You have 4 zeros, right? X is just 10. You see 10,000 compared to 10. This is much bigger than this. So that's why the highest power term dominant the behavior. Okay, so it's like, oh, you get a million. Do you care about a penny? Not that much, right? So the dominant term, the highest power term dominates. Okay, as x getting bigger, 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 the highest power term will go bigger, 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 a lot. Okay, so that's the dominant term. So yes, the end behavior of a function means how the function behaves when x goes to infinity, that's the right hand side, or x goes to minus infinity, which is the left hand side. For non-constant polynomial functions, the end behavior is either y goes to infinity or y goes to minus infinity. So y infinity, that's up, negative infinity, down. Okay? Example, determine the end behavior of the polynomial. Okay, so how do we do this? Okay, so here, when we look at this guy, only look at the leading term. Okay, because all those smaller degrees, they don't affect much. Okay, only the leading term dominates. So when we look at the end behavior, look at the leading term. Okay, so you see, this is x to the 4th. X to the 4th is a even or odd power. Even power. So as long as it's even power, it looks like x squared. Do you agree, everybody? What's x squared look like? Yeah, like that. Okay. Okay. Uh, so x squared is like that. Therefore, x to the 4. So x of the even power, okay, not only square, even power looks like that. And our leading coefficient is -2. Is that okay, everybody? So -2. Well, it means it's gonna be what? Flip it downstairs. Do you agree, everybody? Mm-hmm. The negative it means reflection over the x-axis. The 2 means vertical stretch by a factor of 2. But it's 2 but down. Right, everybody? Okay. Awesome. So now, you see? When x goes to infinity, the y goes to what? Infinity, negative infinity, right? It goes down. How about when x goes to minus infinity? Y goes to negative infinity because it goes down, right? If it goes up, that's positive infinity. If it goes down, that's the negative infinity. So far, so good, everybody? Mm-hmm. Okay, yes. So this is example 1. Similarly, the next example, you look at the leading term. This is x to the odd power. So what does it look like? Yeah, like x cubed. So x odd power looks like x cubed. And our leading coefficient is 3, which is positive, right, everybody? So it still look like that. But maybe it's more skinny because you use vertical stretch by a factor of 3. Okay, everybody? It still look like that. Okay, now can you tell me when x goes to infinity? What happened to your y? It goes to infinity. How about when x goes to minus infinity? y goes to negative infinity. Very good. So far, so good? That's easy, right? You just look at, oh, it's odd power or even power, and the leading coefficient, positive or negative, and you can draw the picture, and then you can figure out. Okay, very good. Okay, note, a zero or root of a polynomial is a value of x such that f of x equal to 0. So 0 corresponds to factors, and graphically they correspond to the x-intercept. So the zeros of a polynomial is not necessarily 0. Okay? So what am I saying? The 0 is not necessary 0. Wow, what am I talking about? 0 is not 0? So, okay, let's look at this picture. This is, let's say, is x minus 1 and x plus 2. You know, this is a quadratic function, right? Because the degree is 2. But then when you draw the when you find the 0, so how do we find the 0? We set the y value equal to 0, okay, and then solve for x. Well, you see, we have the first factor equal to 0, or the second factor equal to 0. So the first factor x equals to 1, the second factor x equals to 2. Yes, everybody? So we get the zeros or the roots, okay, the 0 or the roots of the function are x equals to 1 and x equals to negative 2. You see, the zeros is not 0. Okay, so they correspond to the x-intercept. So if we want to draw this picture, okay, if we want to draw this picture is like 1, okay, 1 is right here, negative 2 is right here. So we have a parabola goes through those 2 points. Okay, so the x-intercept are these 2 points. Okay, everybody? So the zeros of the function is the x value, where the y equals 0, but the x is not 0. It might not be 0. Okay, everybody? Awesome. So let's continue. Example 3. If f of x equals x squared minus 5x plus x, then because f of 2 equals to 0, it must have a factor of x minus 2. Also, there will be an intercept at x equals to 2. Okay. So, because we plug in 2 and then we get a 0, so it must have a factor x minus 2. Like our previous example. Okay? How do we find a 0? We factor it completely. Then we set each factor equal to 0 and we find the roots. Right? So here, if 2 is the root of this polynomial, then that means it must have the factor x minus 2. Is that okay, everybody? Okay, so we can think backwards. If 2 is a 0, then if we factor the polynomial completely, it must have a factor of x minus 2. Okay? Alright, so yeah, there will be an x-intercept at x equals 2. Okay, now how do we graph polynomial functions? First step, we factor to find the 0, and then we plug the x-intercepts. Also, find the y-intercepts. Okay, remember, how do we find the x-intercept? So x-intercept, we set the y equal to 0 and we solve for x. Do you agree, everybody? How about the y-intercept? We set the x equal to 0, right? So that means you plug in x is 0 into our function. Okay, so you find what is f of 0. Then you get the y-intercept. So far, so good. Okay, plot the test points between the x-intercepts and then determine the end behavior in graphics. Okay, so these are the steps. Now let's do one example. Okay. Sketch the graph of the following. Be sure to show intercept, test points, and end behavior. Okay. So, first of all, let's factor completely. Can you see a common factor? X. Yes, everybody? Do you see the leading coefficient is negative? So let's also factor out the negative one. Okay? So if you see the leading coefficient is negative, please factor out negative 1. So we factor out negative x. What's left? And then what? Minus 3. Very good. We put the sign of all the terms, right? So the positive 2x squared becomes negative 2x. Positive 3x becomes negative 3. And then, can you factor further? X. Yeah, very good. Plus 1 and minus 3. Are you okay with factoring? Okay. Yeah. So remember I gave you more exercise on the Mobius lessons. So if you need more exercise, go there and practice. Okay, very good. Now we set this equal to 0. Okay, that means each factor equal to 0. So we have x is 0, x plus 1 is 0, or x minus 3 is 0. Okay, what's x? Negative 1 and 3. Okay, so the zeros, or you say the roots are x is 0, 1, and negative 3. Okay, how about the x-intercept? Well, that will have 0, 0, negative 1, 0, and 3, 0. So they are the x-intercepts. Okay, remember x-intercept is on the x-axis, so y-coordinate is 0. Right, everybody? Okay, how about the y-intercept? Well, to find the y-intercept, you evaluate f of 0. But do you see if you plug in x is 0, what happens? It's just 0. Yeah. So that's why the 0, 0 is not only x-intercept but also y-intercept. Is that okay, everybody? Mm-hmm. Awesome. So we have the real number line, and then this is the x-axis, but you also need to draw the y-axis. Okay? So we put the x-intercept. They are 0, 0, so negative 1, 0, and 3, 0. Okay? So you plot the important points, and please label them. Okay? So promise me you're going to label them. You don't need to label everything, but for the important points, label it. Okay, everybody? And then for each point, figure out a test point. Okay. So, for example, but I want to teach you a faster method. Remember before I teach you two methods? One method is to plug in the test point. The other method is look at the leading coefficient. Because the leading coefficient is minus 1, right? So leading coefficient is negative 1. So we start with the right lower corner. So you start with that, and then you connect this point. Then you look at the 3. 3 corresponds to this factor. Do you see the multiplicity? Remember the multiplicity is like the power of that corresponding factor, the power is 1. 1 is odd. So if multiplicity is odd, we cross the x-axis. So multiplicity is odd, we cross the x-axis. If multiplicity is even, we bounce off. So that's why we cross it, and then when we get the 0 corresponds to x. The multiplicity is also 1. So it is odd. So we cross it, and when we get to the minus 1, do you see the multiplicity is also odd? So we cross it, and therefore, this is what the picture looks like. I think this is much easier than find the test point. See, you have 1, 2, 3, 4, 4 intervals. To find the test point, you need to pick a number and then plug it, and you need to use your calculator. It takes more time than just looking at the multiplicity.